So the next function that we are going to see in the topic queue is display function. We already know, very simple. We just have to travel through our queue and display all the elements that are there inside our queue. So for that I have written up a function. Now here there is one condition that I check. That condition is checking whether my queue is empty. Why? Because obviously I'm trying to display elements. If there are no elements in my queue, you should make user know that the queue is empty. So that is the condition that I check. Empty, where I say if front equal to -1, printf queue is empty. So we already know that if we have a queue, okay, and if my front and rear are at -1, that means my queue is empty. With that, this part, else part, is basically displaying the elements. Now for displaying the elements, I have taken an integer I, and using this particular variable, I'm going to start displaying my elements. Now how am I supposed to do that? I'll take a for loop. For loop is going to help me to travel through my queue, take each value, print it to the user. So let's try to see 10, 20, 30, 40. Suppose this is my queue, and this queue has its front at the first element and rear at the last element. Okay, so I'll start from my front, and from front I'll start displaying my elements. So in your for loop also, your I will start from front. Your I is going to start from front. For I is equal to front, that is the first value. Okay, I hope you know how for loop is executed. There's initialization, there is condition. After checking the condition, if the condition is true, you come inside, perform whatever is there in your for loop. Again, you will be incrementing or decrementing, and from here your condition will be checked again, until when your condition will be checked, till your condition is false. Once your condition is false, it will come outside your for loop. So your for loop execution, we start with front. For I is equal to front, the first value. So I'll check my condition. Is my I less than equal to rear? Is my I value, that is front value, 0? Is it less than my rear? Yes. So yes, 0 is less than 3. Not these values, right? This value. Is my 0 less than 3? Yes. It will come inside and it will print the element Q of I. So what is my I as of now? It is front. That is 0. So my 10 will be printed. Similarly, it will increment my value of I. So I, which was front, now it is incremented. I will point here. Again, I'll check the condition. Is my I less than equal to rear? Is 1 less than equal to rear? Yes. So it will again come inside. It will print the value. The second value is 20. Again, it will increment. Here, my I value is now what? 2. Check the condition. Is 2 less than equal to rear? Yes, it will print the value. Again, there is this condition of increment. My I is incremented to 3. Is my I less than equal to? 3 is equal to, right? So less than equal to 3, so it will print this value. Again, it will increment. Understand this. It will increment this. Now my I value will become what? It was 3, it will become 4. I value will become 4. Now I will check the condition. Is my I less than equal to rear? Is it less than? Is 4 less than equal to 3? No. Here the condition goes false, and it will come out of the group. That is how all the elements from your queue will be displayed. So for this particular function, only this line of code is important, your for loop. You should know how to execute your for loop. You have to start with your front. Now here you will say that all the elements are already there. What if these elements are not there? So obviously I know if previous elements are deleted, that means my front is pointing here. So I start from this element, and I'll display this element. I'll move to the next. I'll display the element. I'll move to the next. I'll check the condition. Condition goes false, out of the loop. Okay, so that is what is your display function. So programs, we have already seen functions of insert, enqueue, dequeue, peek function, and then there is display. So please go through the function so that your concepts of queue would be better. Okay.